This conference will now be recorded.
So good morning everyone. Yeah. Now this is the class 2 of our Devops session. In our first class what we did, just 10 minutes of recall of what we did on first class. We started with this introduction about Devops. So what is Devops? And then in this case Devops is a culture here by which we can bring the entire process of development, software development life cycle in an automated manner. Start from the development up to the implementation in this client environment. So the end client so need to be implemented the application that has been developed by development from the development phase up to this implementation phase. Everything will be automated. Okay, by using some set of tools. Here, those tools, what are all the tools that we have make use of for the software development lifecycle has been discussed. Okay, so DevOps is a culture which brings integration between the development team and the operation team to work in together. The development team and operation team will aware of what is happening on the both sides. Okay, developer will know about these operation activities. The operation team will know about the development activities. Okay, by the way, at the why what it is aimed at, it is aimed at in customer satisfaction, delivering the quality product in a timely manner. That is the delivering of the high quality software. So in a timely manner without any delay and more importantly with less cost. Cost here refers to in terms of resources. The resources may be human resources or it may be a machine resources. Okay, machine resources and then less cost and with very high efficiency. Overall efficiency will be if all this has been assured in delivery at the end the customer will satisfy and we get more business. That's the primary intention in going for this DevOps. So before DevOps, what we have, you guys are aware of the traditional software development lifecycle models. We discussed about this waterfall model. Then in this waterfall model, there are several phases of activities. Like we have a requirement gathering phase. Then we need to go for along with the BA. Okay, the business analyst need to visit this client place to gather the requirement for developing the application. And after that, there will be a architectural meeting. Okay, design phase. So based upon this client requirement, then the architects, the system architect, the solution architect, database architect, all these people involved in this meeting and they will design the solution. So what are all the tools that we need to make use of it? What's the infra architecture that we need to go for? What's the database like thing? And based upon that, a team will be formed. Team formation will take place and then the software development life cycle starts here, software development. And then we form this development team and the development will go on. Once the development has been successful, we go for this testing. And here the testing involves, it may be a unit testing, it may be an integration testing, it may be a performance testing, like so load or performance testing, all sort of testing will take place. Everything is perfect, then it will be delivered to the end client, delivery. Okay, so these are all the phases of activity from the day where the client starts with interacting regarding the requirement gathering up to the delivery in the production where the end user starts working the particular applications. Okay, the drawback associated with these traditional models like waterfall model, it took minimum 5 to 6 months to deliver the application. What is the intention behind the client is looking for, going for a computerized application? So the return of investment. He looks for adding more value-added things to the customers, and as a result, they can get more customers and they can get more profit. And what are all the things that they invested for that particular activity need to be returned back. okay, in a short span of time. Whereas in case of this traditional waterfall model, each and every individual who involved in this activity, so here whether developers or testers or operation teams, under operation team we have several members. We have network administrators, we have system admins who take care of configuring individual system. We have SAN team, storage team. We have database admin. Okay. So here in this case, we have developers, we have testers, we have build engineers. So these are all the members which forms the part of the development team. These are all the members which forms the part of operation team. Each and every individual will focus only towards the goal. The developer will only focus on attention of developing a software model that has been assigned. The tester will intention of tester will be to identify the bug from the developed code. The build engineer will focus only on CI/CD. Similarly, the network and software, they doesn't aware of what others do. That's the way by which the traditional waterfall model operates. As a result, there is a lot of issues, misconfigurations, everything will leads to the poor quality, and delivering the software will take a lot of time, and okay, it involves a lot of human efforts. To overcome from that, what we did here is what they did. They developed the concept of agile. So what is agile? Here it is a divide and conquer approach. So everything that we are discussing now has been taught in a first session in a very in-depth manner. Just a recall of what we have discussed in the class 1. Okay, there are some newcomers further to make it understanding. So we are going through what we have discussed. The agile, instead of developing this entire model as an individual model, what agile will do, for example, it is a banking application that we are going to develop regarding a loan. In terms of loan, let me take, there are three types of loan. One is personal loan, and second one is a home loan, and third one is a car loan, vehicle loan. So if you go for this traditional waterfall model, so all these three model will be developed, and then after development, all these three model will be tested and implemented. Whereas if we go for this agile, now the model has been splitted, and we need to assign priorities. Personal loan first priority, home loan second priority, vehicle loan third priority. Now this first model will be taken, and it will be now designed, architecture and developed. It will deliver to the client. Client start using this first model, and then after using the second activity, the second model will be start development, and this model by model approach will let the client the return of investment that can be returned in a very short span of time. The client no need to wait for the 5 to 6 months of duration. Normally in agile, we call these individual models and the life cycle associated called as sprints. Okay, we call this as a sprint. Sprint 1, sprint 2. In this example, we have 3 sprints. Each sprint may be in need of 2 to 3 weeks. It depends upon this corporate. 2 to 3 weeks of, within that 2 to 3 weeks of time slot, the client will receive a particular model and he starts working on the model. That is the way by which the problem that we have faced in software development life cycle with respect to traditional models like waterfall model has been reduced to great extent in agile. But what's the drawback of agile? Agile focuses only on the development perspective. It doesn't give any attention towards this operation side. As a result, the development activity has been fastened. Okay, here the developer developed the software, integrated, tested, and everything is perfect. Then it is delivered to the client. But being it is delivered 2 to 3 weeks once, what needs to be done on the operation team? The operation team gets stuck with a very huge workload. They want to configure according to the requirement. 2 3 weeks, the configuration need to be changed, the database need to be changed, the particular installation of associated tools need to be revised. Each and everything will result in a huge workload in operation team. So as a result, what happened here? Even though agile, okay, will deliver the software to the operation team in a less span of time because of some misconceptions, because of some hassles between this development and operation team. So here what it is aimed at is not achieved to the full extent. Okay, the development activity has been fastened but the operation activity does not have any improvement here in case of agile. That's the way. Okay, the development activity done very fast, but in terms of this operation team, then there is an issue. This is the problem associated with this agile, but it provides us a little bit advantage compared to that of our traditional waterfall model, which result in inefficiency in both development as well as operation side. Okay, so then what's the solution? How we can make it integrated, development team members and operation team members? How we can make handshaking without any problem, these two members? Here comes the DevOps. DevOps is not a technique. DevOps is a culture which the development team and operation team need to be adapted. Here, the developer apart from this development need to aware of operation, and the operation team apart from this operation, it may be a network, maybe a system, maybe a storage, it may be a database. Anything, any person who involved need to aware of what is happening in the development. So to be a layman point of view, by it is a automation process. By making use of some tools, the entire process of development up to delivery is automated. What the developer need to do here is, the developer need to develop only the software, that is the application. Okay, then taking that code that developed by the developer and doing this compilation and build the code, that is we call this as an artifact, build the application and deploy the application to the test servers. Okay, where in the test servers the testers might have been written some test code, applying the test code on the application, and if identifying the bug if any, in case if any bug, then immediately respond back to this developer regarding the bug, and everything is perfect, taking that application and implementing in the, so these are all the test servers. These are all code has been developed in the development machine, and this is the test server. Okay, this is testing machine, and everything is perfect. This is our production. The application will be installed in the production where the end user will make use of it application. Okay, so this process of development up to this delivery. Okay, so this process of placing this application in this production is called as delivery. Okay, continuous delivery. This is called as the automation of development up to the production delivery can be done by using some set of tools which comes under DevOps. What are all the tools that forms the part? Here first we have discussed about this VCS. This is what that we are going to discuss. VCS stands for version control system or source code management. We otherwise called as SCM. Okay. There is another terminology. CM stands for configuration. Here the source code management. Source code management, or we call it as a version control system. The version, this is what that we are going to discuss here. For this, for software that we are going to make use of it, we can make use of softwares like a Git and public repositories like a GitHub. We have some repositories like Bitbucket, BUCKET, Bitbucket. Okay, we have GitLab. So there are several repositories. This is the tool. Git is the tool which is used to keep track of what are all the things that has been done on the developer side. Okay, we have a discussion so that you have clear understanding. So these two tools, Git and GitHub, comes under VCS, and we have a continuous compile and build tool called Maven. And we will have similar to Maven, we have another tool like Ant. Our discussion is going to be with Maven. And then we have a CI/CD tool called Jenkins. CI/CD stands for continuous integration and continuous delivery. We already discussed. Okay, we have Jenkins, we have Bamboo, we have Hudson. There are several build tools. Here we are going to use Jenkins, and then this tool is called a compile tool. And this is our CI/CD tool, continuous integration, continuous delivery, compile and build tool. So Jenkins internally uses Maven for compiling and building. Once here we have artifact, the Okay, so artifact is nothing but the application, the jar file or a war file, so or a executable file, any file where the application is jam packed in is called artifact. We make use of this JFrag artifact tree to maintain this artifact. And then in this case, we also discuss about some code analysis using Jacoba. Okay, these are all some tools for code review, code analysis, code analysis. Okay, so these are all things which comes under these artifacts. And then we deal with this configuration management tool called Ansible. Okay, similar to Ansible, we have Chef, we have Puppet. Okay, but Ansible is one of the most widely used tools. Okay, we deal with Ansible, and then the most important thing of our discussion. Okay, this one, the Jenkins, complete CI/CD, and here we go for this infra automation. Okay, here we will be dealing with three things. One is Docker, another one is Docker Swarm, the cluster orchestration and monitoring, and then Kubernetes. So these are all the most important things with respect to our curriculum has been concerned. Compared to that of others, we give more attention towards this. Okay. So Docker Swarm and Kubernetes, and followed with we have the infra side AWS cloud. In AWS, we will be dealing with some basic services. We deal with EC2, we deal with S3, we deal with the storage Elastic Block Store, and we deal with some CloudWatch. Okay, this is your CloudWatch is the monitoring services, and then deal with SNS notification. These are all the things which covers under AWS. And apart from that, what we cover here is okay, Terraform. Okay, so here Terraform, and then we deal with finally Nagios for monitoring purpose, and deal with Python for scripting purpose. Here in this case, under Jenkins, we deal with Apache Tomcat application server. So these are all the things, these are all the softwares using which the entire process can be automated. So here, by the way of doing automation, the problem that is associated between this development team and operation team has been reduced to great extent, and as a result the application can be developed with very high quality and efficiency with less time and less resources, and thus reduces the overall cost to a great extent with the highest customer satisfaction. So this is the technology which is adapted both in development side as well as in the operation side. Whether you are a developer or you are an operation team member, if you are aware of this Devops, there is a huge job opportunity that is existing. Okay, in tier 3 cities like Madurai, where I am currently blocks to working, in our company we have around 4 to 5 years of experience DevOps professional. We are paying around 12 to 14 lakhs of salary in Madurai. So here the salary range for DevOps professional around 1 to 3 years, it will be up to 6 to 7 lakhs. If it is 3 to 5 years, it will be doubled almost up to 12 lakhs. And if it is greater than 5 years, 5 to 8 years, it will be around 20 lakhs. And if, okay, so these are all the salary range that's associated with this DevOps engineer. Okay, the another important advantage here, if you want to get upper hand, DevOps along with any cloud, being it is infrastructure, more specifically AWS cloud, will value add the thing. So if you are an architect level people with 3 to 5 years with DevOps with cloud, even you can get up to 15 to 16 lakhs. In this case, you get up to 25 lakhs. These are all the scalar range and the associated job opportunities with respect to DevOps. This is what that we have discussed in the session 1. So if you have any doubt, new entrants, if you have any questions to put across, please let me know.
Hi, Raman. Sam here, Raman.
Yes, Ram.
Uh, See, I thought like GitLab, I understand what are the codes developers are developing. They are just storing it, and all the codes are stored there. And using
Yeah.
Jenkins, can we just integrate all the codes, and using Jenkins, can we deploy?
Yeah, Jenkins will do all these activities that we will discuss now. So that thing has, I think, so whether you have been shared with the class on video, have you had a chance of going through that video?
No, I didn't get any in the first class video. Yeah.
Okay, no issue. I will just give you what happens in CACD. Also, I will share you the demo. I asked that the lady to share the class demo video, class one video, so that you have a clear understanding. No issue. I will share you today the class one video along with the today video. You please go through. Okay, I will let you know what happens in the CACD now. No issue.
Okay, sure.
Okay, yeah, yes. Yes, apart from Jatin, Balaji, any question?
No, I'm good.
Okay. Rajesh sir, do you have any question?
No, sir, nothing. I'm good.
So now, what is CACD? Okay, CACD is the process of continuous integration and continuous delivery. We call this as a CA stands for continuous integration, CD stands for continuous integration and continuous delivery. What is continuous integration? Under continuous integration, we have the following thing. Okay, so under continuous integration, we have continuous development, continuous upload and download, and we have continuous compile and build. I will let you know each and everything, and continuous deployment. So these are all the four phases which forms the part of continuous integration, and we have a separate phase called continuous delivery. Okay, so this is the phase which comes under continuous delivery. First, what happens? Okay, let me first here. In this phase, continuous integration, the development will be done by the developer, and the developer pushes the code into this. Here, this thing happens on the developer's machine, and we have a repository, okay, which is maintained by like a GitHub repository, a public repository. Developer, what he developed, he pushes the code into the repository, that is continuous upload. Here we have this Jenkins. Okay, here we have this Jenkins server configured. The Jenkins server, what it will do, it will look for the repository. If there is any new code that is pushed here, Jenkins will continuously download the code. Okay, it will continuously download the code. Here, this is upload. From the developer side, he pushes the code into the GitHub, that is continuous upload. And when a new code has been found on GitHub, the Jenkins will continuously look for that code. He continuously download the code. Jenkins use tools like Maven or Ant, okay, to do this compilation. Let me take example. The developer RAM developed a particular module. It involves 1.java. It involves 2.java. Okay, these are all the 3.java. Okay, these are all the three things associated with the developer RAM. And then you have a developer, another developer by name Arun. Okay, he developed his own module 4.java. And we have another developer, Rajesh. Rajesh developed 5.java and 6.java. Okay, so these are all the models that is associated with, that is a loan, that more specifically to the housing loan. Okay, all these six programs togetherly will form the application for housing loan. Each and every developer in their machine, they will maintain this Git. Okay, the Git is a software which is used for this version control system. What is version control system? Keep track of what are all the changes that has been done by the developer on the code. Okay, when the changes has been done and why the changes has been done. All those information will be maintained by this version control system. Here we make use of a tool like Git. Okay, so here that RAM developed this code. After that, what RAM will do? RAM will pushes the code into the repository. That is repository is GitHub repository. Okay, we can either configure a remote repository or we can configure repository on our premises. Okay, the private GitHub repository, not local. We call it as a private GitHub repository, or we can configure the public repository. Okay. So once RAM pushes the code, 1.java, 2.java, similarly Arun pushes the code and Rajesh pushes the code here into the GitHub. Then what you need to do, if you are a Java programmer, you are aware that you need to do a compilation. What this compilation will do? It will check for syntax and semantics. Syntax and semantics check. Then once it is perfect, what it will do? It will form a .class file. Okay, now you have 1.class, 2.class, 3.class, similarly 4.class, 5.class, and 6.class. And this is what we do in terms of this continuous compile. And after continuous compilation, I need to form an artifact. Each and every class file need to be packaged into either a Java archive, or it is a web archive, or it is a enterprise archive, or any Microsoft installer application or exe file. It depends upon what language that you are using for development. If it is a Java, then it may be a jar file. Okay, so here this process of taking all the individual programs that is associated with a particular module and to form a jar file, and this jar file we call this as a artifact. This is our application. Okay, this is called artifact. This process is called creating the artifact from the given class file is called as continuous build. Okay, and then what we need to do, now we have all the program which was uploaded in the GitHub. So who will do the activity? Jenkins will do the activity. Continuously development will done by the developer. Once developer upload the code, Jenkins will start from process. It will download the code and it will do the compilation and it will build with the help of the Maven and it will create an artifact tree. Now the Jenkins is having this artifact tree. Let me take it as a project.jar. What it need to do? Now we have another server called testing server. Jenkins, what it will do? The testing server, what is the testing server will consist of? The testers might write down some test codes, some test cases. Okay, here they want to apply this test code on the application project.jar. Therefore, this project.jar need to be bring from the development environment into the testing environment. The process of bringing the artifact into the testing environment is called continuous deployment. Okay, the continuous deployment will take this project.jar and then it will move the project.jar into the test server. For the test server, we make use of this some Tomcat application. Okay, the Tomcat. So here, this test code is developed by the testers. Testers develop the test code. For example, it contains some test cases. For example, let me take it is a login page. Login means you want to give username and password. And these are all the possible test cases. Okay, username and password, correct username, correct password, correct login. Login should be success. Username correct, password wrong. Okay, it should throw error. Username wrong, password correct, it should throw error. Username and password wrong, it should throw error. Username and password is null, it should throw error. Like these are all the possible test cases with respect to this particular scenario. The tester will develop the test code and they will apply the test code on the project.jar. And if the test succeeds, then what happened here is from the testing server, we need to move into another server called production server. Okay, so up to this phase of uploading, up from downloading, compile, build, and moving the code into the testing server and test the program, everything will be done by the the CI/CD. This continuous integration process will done by Jenkins. This is the role of Jenkins. When everything is perfect, what it will do? Jenkins will take the code and and it will move the code from test server into the production server. Here, the production server, once it is implemented, then it will be start used by the end user. That is, the client will start using this. The process of moving from testing server into the production server is called as continuous delivery. So the entire activity will be taken care by the Jenkins, this CI/CD. Now it is clear what Jenkins will do. Now the infrastructure automation, then installing everything, configuring in a very effective manner can be done by using Dockers, containers, Kubernetes with the use of the configuration management tool like Ansible. Now I think
Okay,
so.
Raman.
Yes.
Yeah, Raman. Sorry to interrupt. So, as per my understanding, we need a Git for version control, and for continuous integration and delivery, we need a Jenkins, and for
Yeah.
monitoring, Nagios. So,
Yeah.
can we just achieve by using only these three tools the entire DevOps lifecycle?
No, you can able to do this up to this artifactory, and here the efficiency here lies with the automation on the infra side. What you did so far is for the development perspective. At the development side, you develop the code, developer develop the code, taking the code, building the code, applying the test cases, everything automated. Here comes the infra. You need to set up the server. What do you need? The application need to ensure high availability. That is, the application need to be accessible 24/7. Therefore, you need to establish several servers. You need to configure load balancer. Is it? And then the end user, okay, the application need to be configured this jar file on multiple servers. Multiple client will send a request, and the request will be taken by the load balancer, and it will be redistributed. Like this sort of establishing the infra. So instead of establishing the infra in a manual manner, here too this thing can be automated. Here the resource, instead of spending the cost for this physical infra, we can go with this cloud infra. And here in cloud, we can initially we go for this virtualization like VMware tools virtualization. So from virtualization, we move on to the cloud. Now, the most advantageous thing we can go for this Dockers and containers. The concept called Dockers and containers, and then similar to that of Docker, there is a tool called Kubernetes. So using these tools, this infra can be created. For example, let me take a case in the end production side. I need to set up 100 machines. Okay, my 100 machines need to be set up. These are Linux operating system. I need to install Ubuntu. I need to install, let me make is a Tomcat. I need to install this application, that is your .jar file. So these are all the things that I need to do on 100 machines. Imagine if it is manual, yeah, administrator need to do a format, need to install all the things in a manner. Instead of that, what we can do this in an automated manner using these Dockers and containers concept. Okay, within a fraction of second, I can able to launch these 100 machines. Within 5 to 10 seconds, I can able to launch these 100 machines. And what are all the things that can be configured? If I want to install, for example, MySQL as my database 4, so I can make use of these configuration management tools, which is nothing but infrastructure as a code. Using these configuration management tools, with the help of this Docker and containers, I can create these 100 machines within 5-10 seconds, and I can able to control all these machines from the single server. For example, if we take an Ansible server, okay, from that, if I want to do installation of MySQL 4, what I can do? Simply, I write a small YAML file, and I can push the file immediately. All these 10, 100 machines that is which is running Docker, that is configured with the MySQL 4. I want to do upgradation to 5, no issue. I can do this upgradation on the Ansible server. Ansible server immediately do this upgradation on all the 100 machines within 5 to 10 seconds. So if you do initially manually, it took in terms of hours or days to do this configuration. Here, we can make it automated using this opposite tools in terms of seconds. These are all the second part. configuration management tool, infra tool, Docker container, Kubernetes, this forms the part of infra. This also forms the part of DevOps. The first part, CI/CD, is the build engineer role. You can, if you want, you can opt for a build engineer role. Then if you want to be a complete DevOps architect, this is the second phase also you need to be aware of, and more specifically on the infra automation, infrastructure as a code, Docker container Kubernetes plays a very crucial role as a DevOps architect. Clear?
Yeah. Now you mentioned about Ansible. Using Ansible, we just installed like for example for MySQL kind of thing deployment. So, but you said even Jenkins is set for continuous deployment or delivery. So using Jenkins, can we deploy like this?
What Jenkins will do, Jenkins having this application project or job file, is it? Here, this infra need to be created. That infra can be created by using this Ansible, Docker, and container. Now we have the infra. Now Jenkins will take the project or job and implement in the infra. That is automated. That's all. That is continuous delivery. From the testing server, it will take this application and implement the application there in coordination with this Ansible, Docker, and container. Jenkins part is first part, comes under development. So until from the scratch of getting the code developed by the developer in building this artifact, Jenkins will do, and the infra automation will be done by CM, Docker, container, Kubernetes. Once the infra is ready, this job will be implemented there in infra by Jenkins. Once you go through this, you have a clear understanding. Yes? If you want to be a build engineer, so GitHub and Jenkins is enough. If you want to be a DevOps engineer, it is not enough. You need to aware of the second half.
So Jenkins only integrates the code, and it keeps it like a consolidated code, right? It won't like fully deploy kind of thing.
You won't do anything apart from that.
Okay.
The infra automation, it doesn't know anything about that. For that, we need to make use of the separate tools.
Okay, got it.
Okay, yeah. So, others, any doubt? Is it clear? There are two options. If everything is clear, you won't have doubt. If everything is empty, blank, then too, you won't have doubt. How I can take it? Rajesh sir,
Yes, sir.
option 2 or option 1?
In
Yes to
between,
no.
sir. Now.
Okay. As we progress, it will be very easy. No need to worry about anyone. No need to worry. What you need is just you need to understand my English. That's all. I will make it easy by using some appropriate examples. All. Balaji, I think so. You are a new entrant.
Yeah.
Jadin also, I think so. Jadin also. Whether you attended the first session, Jadin?
No.
No. Okay. No. So what
Okay,
I can
Raman,
do?
yeah, one more question, final question. So
Yes.
whatever
No.
the 10, whatever the 10 tools, DevOps tools you mentioned, all those
Yeah.
tools are like a freeware or paid one?
All are open source.
Okay, thanks.
All are open source. Here, how much of duration that we cover for all those tools is, so let me also know. For this tool, version control system, Git and GitHub, we will be covering up to 8 hours. These are all number of hours. Okay. And then for Maven, we need maximum of 3 to 4 hours. Let me make it as 3 to 4 hours. And for Jenkins, we give more focus for Jenkins. It will be up to 12 to 14 hours, plus or minus 2. And then we once Jenkins has been over, we move to Dockers and containers. Here we have more attention. Here too, we will be having around 12 hours of session for Dockers and containers. And we go for Kubernetes. Okay, so here Kubernetes is equivalent to Docker Swarm. Okay. Then here for Kubernetes, it will be around 6 hours. What are all the things that we taught in Docker Swarm will be replicated, therefore 6 hours. Okay, so togetherly we need plus or minus 2 hours for this. So not minus, it will be more than 2 hours based upon your grasping. And then we deal with this Ansible. Ansible will need minimum of 8 to 10 hours. And then we deal with once it is Nagios. Nagios will need only 2 hours. And if time permits, I will let you know Grafana. Okay, so it will be 1 hour. Okay, it is a graphical monitoring tool. And we deal with this AWS cloud, minimum for 6 hours. All these things that has been listed can be covered. AWS EC2 instance, how to secure your instance and storage, etc., within 6 hours. Okay, and then finally here we deal with this basic Linux administration. If it doesn't have a, and then it will be around 3 to 4 hours of Linux session. So this is the time slot that is associated. Okay, if you take into account 8, 12, okay, plus 12, 24, 36, 42, 50, okay, around 60. Our total time is around 60 to 65 hours. We plan for Saturday and Sunday, starts from 7 a.m. up to 9:15, 9:30. Okay, 2.5 hours of session. Therefore, per week we can able to cover 5 hours of session into 4 weeks, 20. It took, so intermediately we can have a additional time. We can increase the timing up to 3 hours, so that's 7 to 10 like thing, so that I can able to complete maximum within 2.5 months. Assure here 20% will be theoretical concept and remaining 80% will be live practicals with all industries.
Certifications
Yes.
we can do after this course.
Yeah.
What kind of certification can we do after the?
Can you please talk a little bit louder? I couldn't get your voice clearly. It was not very feeble.
What kind of certifications we can do after we complete
Yeah,
this?
you can go for a Jenkins certification. You can go for a Kubernetes certified associate. You can go for DCA, Docker certified associate. Okay, so these are all the certifications. My preference is you go for this Docker certification, which is one of the most demanding and value-added certification today. All these things are open source. You no need to pay for anything. What I need on your side is a machine with, okay, we will be dealing with everything on AWS cloud only. All our infra will be on AWS cloud. Therefore, no need to worry about that. Even if you want to do on your own machine, yes, perfect. You need a i3 machine with 4 GB of RAM. It is sufficient enough. Okay, that is the minimum configuration that we need to do the practicals. And all are open source. You don't need to pay anything.
Raman, there is a certification called Devops certification under AWS. So is that useful?
Yeah. No need to worry about that. In terms of DevOps, what are all the things that we are dealing are open source tools. These are all the most widely used tools. You can apply this on AWS cloud. You can apply this on Azure cloud. You can apply this on Google cloud. Apart from that, AWS will have its own tools like Git, Jenkins. Okay, like we have a code deployment, code commit. Okay, so there are several tools. For example, I will show to you. So those tools will form the part of AWS DevOps. That certification is AWS DevOps. Let I go for this www.aws.amazon.com so that you have a clear understanding of what is. So if you go for this AWS DevOps, that tools is applicable only for AWS. You can't make use it those tools in other cloud like Azure cloud or Google cloud like thing. Whereas if you go for this tool, all the open source tools, out of 100, nearly 90% of implementation is with these tools, open source tools only. not on specific onto cloud services. If you are aware of all these things, then it will be very easy. Okay, now we can find these are all the tools that it is associated. Develop this code start, code commit, code build, code deployment, okay, code pipelining. These are all the 4 tools which forms the part of AWS DevOps. With respect to this AWS certification has been concerned, there are 3 levels of certification, out of which AWS certified DevOps are associated with 1 level. AWS provides you 3 types of certification. One is AWS Solution Architect. Since you asked this question, I am answering this. AWS Solution Architect, AWS Administrator, and AWS Developer, Cloud Developer. So under all the certification, we have initially the associate level, first level, and professional level certification. Similarly, for admin also we have associate and professional. For developer also we have associate and professional. The professional certification for admin and developer is called as AWS DevOps Engineer. The admin certificate we call it as AWS SysOps. This corresponds to AWS Solution Architect, Associate Solution Architect Professional. Here we call this here associate as AWS Developer Certified. Now the professional certification for developer and the professional certification of admin is the same certification. We call this as a AWS DevOps Engineer. Yes, is it making sense?
Yeah.
But these are all the tools out of 100, nearly 90% here it is implemented using open source only.
Raman, you have now nicely given these 9 tools, and it looks like it covers entire life cycle of DevOps. So what I'm looking is just can you just give me like a quick definition, one line definition, what exactly each tool does, kind of quickly, so that I can have like a step by step.
It is a version control system tool, which is used for keep track of what are all the changes that has been done by the developer, and then the changes that has been done, when the changes has been done, why the changes has been done. It will be maintained by Git and GitHub. Maven is a tool which is used for the compilation of the source code and building of the source code. Jenkins is the tool which does the CI/CD process that we have discussed with the help of Maven. And then here to create this infrastructure, so this tool is called configuration management tool, which provides infrastructure as a code. You can create the infrastructure through means of certain scripts, okay, using Ansible. And these tools, Docker, container, and Kubernetes, which is used for infra, okay, to create this infra. Okay, the infra can be created in an automated manner using Ansible. And this Nagios and Grafana are monitoring tool, okay. And then this AWS cloud is used for, once again, either we can go for Docker, container, and Kubernetes, or we can go for virtualization, okay, virtualization concept, or you can go for this cloud concept. So these are all the things that is associated with the one line.
So Jenkins is used with the help of Maven. Jenkins and Maven will go hand in hand, or
yeah, it is integrated. Jenkins is the master. Okay, Maven is the slave. Jenkins internally called Maven for this compile activity and build activity. Jenkins plays a crucial role. If you take the number of hours that we devoted for Jenkins is up to 14, whereas for Maven 4. I need to let you know what is Maven, what are all the life cycle phases, how we can make it. Everything is under it is abstracted. Maven will be abstracted under Jenkins. Consider Jenkins as a superclass, Maven as a subclass. if you are a developer. Yes, clear?
Thanks. Yeah, thanks, Raman. Get clear.
Any others? Please, others, let me know. Whatever may be the doubt, no need to worry about that. Kindly let me know. I will clarify with the right appropriate exams.
Okay.
Jatin, Balaji.
No, I don't have any doubts.
Okay, okay. Okay. What I can do, I will share you both yesterday's session and today's session, and you please go through that, and we can have our first class on tomorrow. Let me start with first session of what is Git and what is GitHub.
So, Raman, when this session? So, how are you going to
Can you talk a little bit louder? I think so. Somebody is trying to say something. Jadin, it's from your side. You have any questions, Jadin?
No, I don't have any questions. No, I think these are all basics. So,
Jatin, I couldn't get your voice clearly. Can you please talk a little bit louder?
1 minute.
No question. If yeah, you can also type it in your chat box. Okay, no issue. If you have any questions, you please type it in our chat box.
Hello.
Yes.
Yeah. So what I'm trying to say is like my question is these concepts are very understandable. So it is these are all like basics. And my concern is like on what days you're going to have the sessions.
And what?
I mean, is it on the weekdays or weekends?
So that's what I had discussed. It is weekend only, not
Oh,
on
it's
weekday.
oh, okay, okay.
Weekend
Oh,
and 7 a.m. up to 9:30 a.m. IST. All are
oh,
IST.
okay, okay, okay. Yeah, that's all. That's all I have.
So all the sessions will be recorded, and we will get a
Yeah,
recording.
definitely. You will be get the recordings. You will be getting the all the commands that is associated documents. But all the thing what I do is first the session has been split up with the following manner. So the 20% we will start with the concept behind that. So if it is Git, what is Git, what is GitHub like that, then followed with the installation of that particular tool, and then doing the practicals of all the associated. I will do that, and you can and the documents associated with installation and practicals along with this recording of the day will be shared to you. Then you once the session has been over on the day itself, you can do the practice on your own machine, and in case of any doubt, feel free to revert me. Okay, and I will let you know the solution. We can form a group, a WhatsApp group. Under WhatsApp group, what are all the problem that you face, you post in the WhatsApp group, and I will let you know the solution on the group itself. No issue. This is the way of our class will be orchestrated.
So the Linux knowledge is required. Is it mandatory? Because I don't have a
That is
hands-on.
mandatory. Yeah, that is mandatory. Without Linux, nothing can be done here.
So it will be.
We I will let you know to which extent that you need to know the Linux. We will cover in the curriculum. Even if it doesn't have, no need to worry about that.
Okay, thanks.
Yes. Any other question? Please feel free to clarify. Balaji, you are from
I'm from Singapore.
Singapore. Have you ever before attended any session of mine under JPA?
No. My friend actually got trained by you. His name
Okay.
is Asila. So he referred.
Yeah. Can you please let me know the name of your friend?
Yasila.
Yeah, Sheila. Yeah. Last week, I think so. She attended.
Okay.
Okay. Jadine, you are from? Hi, Jadine.
Yeah, I'm sorry. You're asking me some question, Raman?
Yeah. You are from where?
I'm from actually States. I'm from Chicago.
Okay. Currently, what's your position? What's your role, current role?
I'm actually a WebSphere architect. So
Perfect. Yeah.
I just want to get into DevOps. So
Very
that's the
perfect.
reason. Yeah.
Okay, Jadine, I assure you that what are all the things that has been covered is sufficient enough to put
Yeah,
in
yeah.
your up to 4 years of experience.
Sure.
Oh,
So will these sessions will be shared to me, Raman?
yes, definitely.
Okay. Okay. Yeah, that's all I have.
Yeah, I will share this. I will share everything.
Okay. Sure.
Sam? Yeah, yes. Okay. We meet again on tomorrow, the same time 7. Okay, thanks a lot. Have a good day. Bye. I will share you the recording of the day 1 and day 2. If you are interested, you can share this with your friends circle also, and you can attend for the tomorrow session free of cost. No need to worry about. You could evaluate my capability and how the sessions will be going on. You can attend tomorrow session, and if everything is perfect and if you want to continue, feel free to contact the concerned person for other things. Thanks, and
Thank you, Raman. Thank you very much.
Thank you,
thanks a
sir.
lot.
Thank
Yeah.
you.
Thanks, Raman. Thank you.
Thanks.
Tomorrow session is
Thanks.
at 7. Thank you. Not on 7:30. Tomorrow we started at 7 a.m. Thank you. Bye. Have a good day. Bye.
Thanks.
Thanks. Bye.